morning and good evening, everyone present here. I am Anshika, along with Harshvardhan, Meghna, and Vishnu, to present our end of course AI 5 project, Perception.ai, where we deployed the text to image generative model. The task at hand for our project was to take a textual description, that is an image caption, and to give out an RGB image. So why do we need text to image? What will be the applications of Perception.ai? In artificial intelligence, there is a massive problem of class imbalance. And with Perception.ai, we will be able to generate images of rare classes which otherwise occur infrequently or maybe not at all. For example, the nucleus dataset for pathology slides of skin cancer. The ratio of the rarest class to the most prominent class is 1:12,250. The other application of Perception.ai may be the MOSMED dataset, which contains the human lung CT scans with COVID-19 related findings. Here we have 5 classes and we can see the classes are highly imbalanced. So our project workflow kind of looked like this, where in the proof of concept phase, we performed data collection and we established experiment tracking systems. After that, in the prototyping stage, we set up our baseline models and even explored better models. In the MVP stage, we set up our project containers and deployment stuff. And at last, we built our application as a product. The technologies we used in our project were TensorFlow, PyTorch, Ansible, Docker, Google Cloud Platform, React, Git, and Python. Our dataset was the CUV dataset, which had roughly 12,000 images for 200 categories of words, and each image had 1 bounding box for object detection and 10 corresponding captions. Next, Harsh.
Yeah, so I'll be explaining the modeling part. So let's first take a look, a high-level look at the generative model, the generative adversarial model. So the idea behind generative adversarial model is that we input a noise vector, and the generator needs to generate an instance of the data, which will be a fake data. The discriminator model compares that fake data with the real data and classifies if it is a fake or not. The idea is that the generator model should be able to generate a data instance which is indistinguishable from the real data. So how does this problem statement translate into text to image? The first paper that came out was in 2016, in which a sentence embedding was concatenated with the noise vector and imputed in the generator network. After that, the discriminator then decides if the generated image was fake or not. Next slide, please. The problem with this type of network, the simple network, was the output image was not crisp enough, and it was not a good substitute for real images. In the same year, a new model was presented called the StackGAN model. There were 2 important ideas in the StackGAN model. The first idea is the conditional augmentation block. The conditional augmentation block allowed the model to be more robust and allowed it to have a higher randomness. The other idea was, instead of outputting directly a high resolution 256 by 256 image, the text description was upsampled and a low resolution 64 by 64 image was outputted. This output was then fed into the second stack model, and a high resolution 256 by 256 image was outputted. This allowed the model to give very crisp images and overall good results. But you can see there is a glaring problem with this model. The input is a sentence embedding vector. So basically it takes the caption, converts into a embedding the entire caption. So we wanted word level features in our model. We implemented StackGAN model from scratch, and the improved model was the attention GAN model. In the attention GAN model, The attention GAN model extends the idea further, and the two important features are as follows. The first feature that the attention GAN model has is the word features. So basically, the caption goes through a text encoder, which is a bidirectional LSTM. It generates a sentence feature as well as word features. The word features are imputed to the to the generator in the first layer and in the second layer. This allowed the model to have rich understanding of the embedding space on a word level. The second idea was the Damson laws. The Damson laws basically what it does is when you have your image, the high resolution 256 by 256 image, that is passed through an image encoder. The image encoder is basically an Inception v3 based encoder. After passing through that image encoder, a latent space feature vector is generated for that image. This is associated with the word features that we first saw are bidirectional LSTM generated, and a matrix is formed, which allowed us to have a score between the text, the word text, and a particular area in the image. We used the pre-trained model weights for the attention GAN model and deployed it using the tech stack that Vishnu will talk about now.
So next we come to the deployment phase. So first we code our model, train it, and code our front end as well. Then we compartmentalize all the code into containers, separate containers. We basically have two containers, which is the PerceptionAI app image, which deals with our front end, and API service image, which deals with our backend. We push both of these containers into Google Container Registry, from where it is pulled and installed into a compute instance VM on GCP. So whenever a user comes and requests, the request is forwarded to the Nginx container, and it forwards it further to the front end. The front end takes in the image, the captions, and it forwards it to the API container. The API container then reverts back an image. Over to Meghna.
Yeah, so let's get into our working part of the model. So this is our URL. You can try it out. It's http perceptionai.dlobs.io. So let's get into our demo. All right, so this is how our interface looks like. So we can type out our input and click the generate button to generate an image. So let's start with a simple image for now. Let's say a white bird with red wings. All right. So it takes the text and generates an image for us. So let's see what our model percepts. Okay. So when we say word white, this is where the model is looking into. Okay, so let's try a fun one. Just say a puffy bird, maybe. Okay, let's see what our model comes up with. All right, looks cute. So let's see what it percepts. Yeah, the word puffy. It's looking into the horizontal dimension. So let's try one other image. Maybe let's try a long one this time. A white bird with a long black beak. Let's see.
You're missing the word bird. Oh, you got it.
All right. Yeah, I can see the beak. It's looking good. Yeah, it's focusing on the long and white color. All right, the fun part ends here. You can try out the app, and let's go back to the slides. So future work. So we want to create an API service where one can upload image and captions data to train the generative model remotely. And we would like to extend this idea of generating images to generating 3-dimensional images and videos using GANs. Such architectures can be useful in forecasting applications like weather prediction, autonomous driving, etc. So that's all for our presentation, and thanks for being a wonderful audience. Thank you.